Okay, here we are with Lesson 5, Graphs of Functions and Equations. So this first part, you're going to do exercises 1 through 3. You're going to check your work as you go by continuing the video. This should take you about 15 minutes. And then there will be a discussion about the exercises when you are finished. Again, anytime you run into something that you don't understand, make a note of it, but continue working through the rest of the problems and bring your notes to class and we can discuss what is confusing to you. Alright, go ahead and start exercise 1. And as you complete each part, A, B, C, and D, go ahead and continue the video to check your answers. Alright, you should be done with 1A. Go ahead and do 1B. If you are done with 1B, here is the answer. Continue with 1C. Right, you should be done with 1C. And continue with 1D. Remember, you're stopping the video after each one. Right, you should be done with 1D. And check your answer. Alright, so here we are at 1E. You're going to be doing a graph here. Alright, you should be done with 1E. And you should have something that looks like this. Go ahead and do 1F. You are done with 1F. Here's the answer. And 1G. You're finished with 1G. Your answer should be this. Alright, continuing on with H. Here is the answer to 1H. And I. And here's the answer to I. And now J. And your answer for part J. Alright, moving on to K. And here is just a sample. You could have picked any number of points. They chose 42 and 6 and ended up proving that it is a function of an output assigned to an input. If you picked a different point, you should have also come up with a true statement at the end. Okay, do L. If you graph equation y equals 1/7 x, then you should notice that the function and the equation coincide. And for number 2, sketch the graph of the equation y equals x squared for positive values of x. Organize your work using a table below and then answer the questions. Again, start with the first value of x, plug it in, and that will give you the answer for y. And you should have a table that looks like this. Alright, part A, or 2A. Plot the ordered pairs on the coordinate plane. You should have gotten something that looks like this, with the points that kind of go up at an angle. So it appears to take the shape of a curve. So for part C, your answer is no, it is not a linear equation. And for part D, part D would just A takes the place of Y and S takes the place of X. Continuing with part E. And the answer. And part F. and the answer for part F. Okay, exercise 3. Here's the answer for 3A. And for 3B, the answer is y equals 32. Okay, continuing with C, D, and E. Here's the answer to C. And after you've answered part D, here is the answer for D. And for part E, here are the answers for, or some of the coordinate points that you would have. Then you are to graph this for part F. Points appear to be on a line. And for part G, it is continuous because, again, our input is a value of time, and time can be done in fractional parts. Part H, you would end up with 6. And answering part I, points would fall in a line. And for part J, the answer for part J. Moving on to K. You could pick any point. The sample point they picked was 520. You could have done a different point. But again, you should come up with a true statement showing that it is a function. And last but not least, sketch the graph of the equation y equals 4x. And you should determine that the equation and the function coincide completely. Alright, so let's go ahead and discuss those answers. What was the rule that described the function in exercise 1? The rule was y is equal to 1/7 times x. Given an input, how did you determine the output that the function would assign? Well, if you use the rule and in place of x we put the input, the number that was computed was the output. So when you wrote your inputs and corresponding outputs as ordered pairs, what you were doing can be described generally by the ordered pair x and 1/7 of x. Take a minute to make sense of the ordered pair and verify that it matches your work in exercise 1. So go ahead and check a couple of different ordered pairs to see that it is, or it does work with x and 1/7 of x. When we first began graphing linear equations in 2 variables, we used a table and picked a value for x and then used that x to compute the value for y. For an equation of the form y equals 1/7 x, the ordered pairs that represent solutions to the equation can be described generally by x and 1/7 of x. Why? Because y is equal to 1/7 of x. So the y coordinate can be substituted with the expression 1/7 of x. How does the ordered pair from the function compare to the ordered pair of the equation? Well, the ordered pairs of the function and the equation are exactly the same as you noted in the exercises. What does that mean about the graph of a function compared to the graph of an equation? Well, it means that the graph of a function will be the same as the graph of the equation. Can we make similar conclusions about exercise 2? You should have verified that the conclusions about exercise 2 are the same as the conclusions about exercise 1. What ordered pair generally describes the inputs and corresponding outputs of exercise 2? We should have said x and 4x. So what ordered pair generally describes x and y values of the equation y equals 4x? Well, again, it would be x and 4x. What does that mean about the graph of the function and the graph of the equation? Again, it means that the graph of the function is the same as the graph of the equation. For example 3, you began by graphing the equation y equals x squared for positive values of x. What was the shape of that graph? Well, you should have said it looked curved. The graph had a curve in it because it was not the graph of a linear equation. All linear equations graph as lines. That is what we learned in Module or Unit 4. Since this equation was not linear, we should expect it to graph as something other than a line. What did you notice about the ordered pairs of the equation y equals x squared and the inputs and corresponding outputs for the function a equals s squared? Well, the ordered pairs were exactly the same for the equation and the function. So what does that mean about the graphs of functions, even those that are not linear? It means that the graph of a function will be identical to the graph of an equation. Now we know that we can graph linear and nonlinear functions by writing their inputs and corresponding outputs as ordered pairs. The graphs of functions will be the same as the graphs of the equations that describe them. All right, let's take a look at Exploratory Challenge or Exercise 4. Complete the work and continue the video to check your answers. All right, so for Exercise 4, it asked you to examine 3 graphs. Which of any could represent the graph of a function? So you have a look at graph 1. So this is a graph of a function. And because each input has a unique output, it is a function. Graph 2 is not a function because x, this input, has 2 corresponding outputs, which means that it can't be a function. Graph 3, even though it's not linear, it is a function because, again, each input along the x-axis only has 1 corresponding y output. All right, so we know that the graph of a function is a set of points with coordinates of an input and corresponding output. How did you use this fact to determine which graphs, if any, were functions? Well, by the definition of a function, we need each input to have only 1 output. On a graph, it means that for each of the ordered pairs, the x should have a unique y value. Assume the following set of ordered pairs is from a graph. Could these ordered pairs represent the function or the graph of a function? We have 3, 5, 4, 7, 3, 9, and 5, -2. You should have said no because the input of 3 has 2 different outputs. It does not fit the definition of a function. Assume the following set of ordered pairs is from a graph. Could these ordered pairs represent the graph of a function? -1, 6, -3, 8, 5, 10, and 7, 6. You should have said yes because each input has a unique output. It satisfies the definition of a function. So which of the following 4 graphs are functions? Explain. Go ahead and stop the video so that you can take a look at these carefully before answering. Okay, graphs 1 and 4 are functions, graph 2 and 3 are not. Graphs 1 and 4 show that for each input of x there is a unique output of y. For graph 2, the input of x equals 1 has 2 different outputs, y equals 0 and y equals 2, which means that it cannot be a function. For graph 3, it appears that each value of x between -5 and -1, excluding -5 and -1, has 2 outputs, one on the lower half of the circle and 1 on the upper half, which means it does not fit the definition of a function. Let's go ahead and wrap this up. We know that we can graph a function by writing the inputs and corresponding outputs as ordered pairs. We know that the graph of a function is the same as a graph of the rule or equation that describes it. And we know that we can examine a graph to determine if it is the graph of a function, specifically to make sure that each value of x, which are the inputs, has only one value of y, which are the outputs. Right, see you in class.